pick it up. thought they go up yet.
No, it didn't, because that's why Tom said to get involved in the show. Because so you could pick where you want to sit.
You were 22nd in Vanderbilt 5 minutes ago. You're standing out of your way.
If I wanted to turn the camera around, I couldn't write a better script. So, at the final push now, they're using a couple of come along here to get this baby into speed, into position. And even with that massive weight, who said a little bit of human brawn doesn't go a long way? Yes, I'm using just about the dirtiest window that allows me access, but it just happens to be the clearest one. Yeah. And you get your parts into a pivoting point where 180, 210-pound guy really come into play. Standing in the right place. Yeah, so now you have to pivot the front up. Bam. That one's gone. That one's the end. That one's in. And that one's sitting pretty close. Yeah, that one's there. That one's there. Now you have to just pivot the front up. Bam. Yeah, and that's the hit that hit. If you could hear that as a machinist, you listen for that hit in many an application. That says both pieces are square. And as was designed, that force fit just made its match. I'm on this dirty ass window. Yeah, so what they did is they got the bottom in and then just pivot her up and she's locked in 4-point. Now that come along can get out of there. As they finish tying that up, you see those steel jockeys. see the joint. And that's where that is. I'm thinking, because where they just made that coupling, that connection. Let me see. Oh yeah, yeah, there is support. There is support there. But you know what? There is support under it, but that's where it is. It's under it. That's not, it's not exactly. So that right there, as it was designed, is holding its own weight. That joint right there is holding its own. That support is just there for if something go wrong, because it's not laying flat on it. You see, you'd have to put a shim under that. But why would you do that? You know, because that's a piece of machinery that's made for that joint to pick up weight. So as a precaution, yes. But that joint right there, that 4-point pin system, has to be like at least 10 times able to hold that weight from there, the yellow section. So it doesn't need to be in contact with that support. Just as a precaution. A redundancy says. But it doesn't have to be.
Immediately, I'm like, ah, you're not.
It would be crazy if it had to be, you know? And that's where those force fit pins, those precision made pins, that 4-pin that just went into all 4 corners, that's where the force fit come into play. Because most machinery you find wear out because of a loose fit. And it's always been my thinking that Japanese car need less tuning, because their tolerance system, when that part is machined, you know, one part being different from another, has to be so close, 1/1000 of an inch, you know, 1/2000 of a and they don't use inch. That would be metric. Yeah. So you find where that pin just went in, those 4 pins just went in. That fit is so great that there's no play in that final piece of that lifting arm. And like I said, the wood is right up next to it, but it's actually floating above the wood. So the wood that they put in the front actually would lift that crane up as they pound the support under it. Yeah. Hear me running my mouth again. You was enjoying yourself, huh, without hearing me talk. and it'll be interesting to see who's gonna hoist this piece in. We know, well, I don't really know if the chuck had lift the entire arm into place last time when it constructed number 1. And what he's doing is there's a rail system that runs along the entire length of that arm, and they're putting those together. They're pinning those together. So in essence, at the top, you have a further strengthening or binding, strengthening, because the joint still remains there. If you would stagger the joints at the top, you would say a binding, but that's more of a, yeah, strengthening the joint. Wait, what they're putting at the top, man? So let's see how they lift this, because I don't know how that chuck crane, I don't know if they brought another crane in or what. But why would they, huh? Let's see. Sit back, relax, and see where it's at. Okay, that wind is T1 in motion. I don't know. No, that's actually the truck crane that's in motion. That's whole Chucko at work. And that's the motor and cable for
So I don't know if the only thing because Tom asked me, said there's something
for T2.
we would want to take a look at, and I said, I don't think it's right for us. Maybe we don't have a reason.
Yeah, that's the motor. That's the main lifter. That's the brawn. Of that behemoth. That's what's going up.
But I just want to know.
In my pocket, $160 million. that's the winch. That's the winch system of T2, and there's an identical one in a T1. And as it has turned right now, it's turned southeast of where it's gonna sit. Yeah. Good. And it's moving, I mean southward. Yeah. Sitting southwest. Not southeast, southwest. And it's moving more westerly of where it's gonna sit. So it's sitting about 90 degrees off its center to the right. It's off its center to the right. And he's moving that up pretty slow. Whether it's because of the weight or because it's so intricate that you don't want to shake that around, because there are parts in the center of that you don't want to have to pull that down. If you get a leak because of a bad jerk. So they're swinging it back towards the direction that it'll sit. I don't know. Actually, that they're lowering is the tippity top. I'm taking wager whether that's gonna go first or the arm is gonna go next. Which would be first? That's gonna go first or that's gonna go first? You certainly got enough ballast up there now for that arm. one and that's couple there. That's give it up. Gotta go up. Gotta go up. Hey, who keep turning that like that? It's gotta go that way. Yep. In and up. It's right there. See how the experts do that. You know, I gotta put my 2 cents in there like it's worth anything. It's right, they've got it right there though. Yeah. You can actually see through that. Yep, and it's going right in. Boy's got a forearm like an orangutan. You wise ass. Shit, I've got a forearm like a gorilla. Look at mine. You see that? But his is a little bit lighter, so he's got the forearm of an orangutan. Now drop down. Now drop your weight down some. and she pivots right in. Don't drop too much. It's gonna be interesting how they get that in, because the fit is so tight. The fit on that is so tight that after they put the paint on, after it was painted, that tolerance that was calculated, so they got to do adjustments now to make it looser to get it in. And what they're gonna have to do is get some kind of weight on the point of that so it can go in, because after that was painted, or for whatever reason. So what's going on is that I was talking about force fit and it looked like the calculation on the measurement, the inside-outside measurement of those two pieces are so close that after it was painted, the paint has caused it to be so small, but that they can't get that last piece in. You see where it's sitting? You need to pivot down that way to go in, but it should slide in and then the pin go in, because those two pins should have it square enough to where it can go in. But it looked like the paint or something, or a burr or something, is keeping it. So what's gonna have to happen is that they're gonna have to put some kind of pressure on the front end of that. Yeah. Front end over here, they're gonna have to put some kind of weight, and the pins are coming back out, so it's gonna be interesting to see. Yeah, they're taking the pins back out, and immediately when the pin came in, you saw that edge kind of slide in. So I don't know if there was so much friction, or maybe the pins developed some kind of groove that wouldn't allow it to turn or pivot, I would say. Yeah, so maybe the bottom end got to go in first, but I don't see that here because it's all square. But who knows? Well, let's see. That's interesting. They totally took that front piece out and they hoist this up. So now it's sitting at an angle. I would support that section here separately from there. From where that pin is, forward of that pin system, I would support. right into the yellow, where the yellow start, and that bar is going across. Matter of fact, there's a piece of wood that's built onto that, that's lashed, that's screwed onto that. Yeah, that's bolted onto that first rail. So I would support forward of that. From there, that piece of wood that's on there, forward. But those are the experts. Because what's gonna have to happen is that front end is gonna go up higher. And when it goes up higher, then you can work more with whether or not. So they're building a more rugged support there. And you got about 2 inches here, go up. There you go. Now come down on that. Yeah, these guys got what they're doing. And now when you put that in, if you have the same problem, then the point of that on both sides of that pulley, that's where you concentrate your placement of weight, hit, whatever it's going to take for it to pivot down and into place. And they might even go in bottom first. I'm thinking that's what they're going to do. And then use the crane if necessary to pull that pulley up into the air and into place. So you make your first 2 connections. That's what they're setting up for. And that's what I would be setting up for. That I make my first 2 connections at the bottom. Then if I need be that force tolerance come into play, I use my crane to pivot up. So let's see if they do it the way that it is to be done, or my way. The way that it is. The way that works. Big Chuckle has delivered the main winch to that tub system. The winch to that tub system that is already loaded with its cables. And those boys are strapping her in, bolting her in as I speak. As this goes.